Hello everyone, and welcome to the third episode of STEAM TV from the North Hastings Public Library. My name is Emma Defo, and I am so excited to bring today's episode to you. Today we are going to be looking at engineering. We're going to be looking at engineering through two super fun activities that will help to teach us some key concepts in engineering and hopefully help pique your interest. So as you can see, I've got some Lego laid out around me here. So the first activity we're going to start with is called the Lego crane. So for the Lego crane, we're going to need quite a few blocks. As you can see here, we're going to need 18 2x4 bricks. Now when I say 2x4, I mean width by length. So and I'm counting by the little dots on the bricks. So you can see we have 1, 2 dots, and then 1, 2, 3, 4 dots. So 2x4. And we're going to need 18 of the bricks. And then we are going to need 4 2x8 bricks. So you can see we have 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8. So we're going to need 4 of these. And then we're going to need 1 4x6 plate. I have here 4x6. And then we're going to need 3 1x2 blocks to look like this little guy. So 1x1, 2. We're going to need 3 of these. We're going to need 1 2x2 brick. And then we're also going to need 1 2x2 brick with axle points on either end, so you could put a wheel on it, and we're also going to need a wheel. We're going to need 1 2x6 plate, 2x6 right there. We're going to need 2 2x3 plates, so those look like these, 1 2x1 2 3. And then we're going to need 1 larger block. We're going to use it as what is known as a counterweight, which we'll talk about a little bit later. This is the block that I'm going to be using. See, it's a little bit larger and can just, it can be any block that you have at your disposal. Anything really works. Yeah, this is the one that I'm going to be using if you would like to use the same one. And then we're going to need 2 2x4 plates, which I have here, 2x4. We're going to need 2 of these. And then we're going to need 1 base plate. I used one that is 8x16. You can use any base plate that you have on hand. This is just the one that I wanted to use. And then we're going to need 1 6x8 plate, which is right here, 6x8. And then 2 1x6 plates. You can see we have 1x6. And then various blocks with a 1 dot width, like this one has a 1 dot width. So does this little one here. Just various of that. And then we're also going to need at least 1 Lego character. I have 2 with me. Oh. I have 2 with me here, and then we're going to need some string. I found that bracelet string worked best, but try whatever you have on hand. And then we're ready to get building. So firstly, we're going to take our base plate, and then we're going to take our 2x8 blocks, these ones here, the longer ones, and we're going to stack 3 of them on top of each other. Make sure they're pressed nice and closely together, so since they are the base blocks of your crane, so it'll be nice and tight, and that will help them to hold up the crane better. And then just place them near the middle on your base plate. That's where mine are going. They don't have to be quite in the middle, just as close as you can get it. And then we're going to take our 18 2x4 bricks, and we're going to put them in the middle, just like that. So they're just in the middle of those 2x8 bricks. And then we're going to stack all 18 of them on top of each other. Now really make sure that these are pressed in well, so they're nice and secure, so your crane does not fall into pieces, especially when you try and lift something up. And the last few blocks. And there we go. There is the base, or I guess the body of our crane. And next we are going to build the very top of the crane. So take your 2x8 plate and that axle block that we had from earlier and place it right on the end, so one axle is sticking out at the end of the block and the other one is inside, and then just place the wheel on the outside so it looks something like that, and you can move the wheel quite nicely. And then place that in the middle of the very top 2x4 block, and also in the middle of that plate with our axle and wheel on it. And then take your 2 2x3 plates and place them right next to the plate on top of our 18th block, just like that. And that levels out the surface so that we can better secure this top block. Now take that 2x8 block here, the last one, and place it just behind the axle block, so it looks something like that. And then we're going to take those 3 1x2 blocks, just these ones, and the 1 2x2 block, and place it on. And now we have a nice level flat surface onto which we can place our 4x6 plate, which helps to secure everything nice and tightly in place, just like that. And then we can attach our counterweight to the back opposite the wheel, so it looks something like that. You see our counterweight on the back there. Now you may be noticing the crane tips to the side pretty easily. Not so much to the front and back since we placed it near the middle on our plate, but definitely to the sides. So to help with this, we're going to make some stabilizers. To do that, we're going to take our 2x6, believe, yes, 2x6 block, take a 2x4 plate, place the 2x4 plate right underneath so they form a T. Do that twice, so then you have 2 T's, and then place the bottom end of the T right behind the crane, right underneath the counterweight, about a 2x2 distance in, as you can see right there. And that's just going to help the crane from tipping from side to side. And now there's our crane. So let's build something to pull up in it. So we're going to take that 6x8 plate and cover it in squares with our 1 width blocks. So what we're doing here is making a cart. And in this cart we can put our Lego people, so we can lift them up with the crane. And that's why I didn't specify a number of blocks for the cart as well, just because it can be whatever you have, as long as you can do 2 levels. As you can see right there, there's my first level done on the outside, and then we're just doing the second level right there. That will keep the Lego people nice and secure so they don't fall out of the crane. just put on the last few blocks, and there we go. There's a cart. It's 2 blocks high, and it has a width of 1 of the little dots on the Lego. Now, to pull this up, take those 2 1x6 plates that you have, place them in the middle of the cart, just like that, so we can find the balance point there. Now you might be wondering, why 2? Why not just 1 plate? Why not just 1 of these? So as you can see, when I hold it here, our cart falls on a bit of a diagonal. That is because the plate that I'm using is 4x6. Now since 6 is an even number, there is no exact middle that isn't a decimal. What I mean by that is when you have 6, you have 3 and you have 3. It divides completely evenly. So there's no 1 block, in this instance, there's no 1 block in the middle where I would be able to find the balance point. It would be a decimal. And with, let's say 5, if you have 5, you have 2 blocks on one side, 2 blocks on the other side, 1 block in the middle. Now that would be your balance point. We will talk more about balance points in a little bit, but in this case, if I use 2 blocks, you can see I have 3 dots on this side, 3 here, and the same on the other side. And that means we have a good balance point. And now around those blocks, I'm going to take some bracelet string, loop it around and underneath. This can be a little bit tricky. There we go. And put it in the middle of those blocks you have there. So leave 3 little dots on either side of the string. Give it a good double knot. And there you go. We have our cart. And all that's left to do is place our Lego people inside of it, just like so, and then take our crane. Now for this, you're going to want to take string, put it over the wheel. So the wheel, it does work best when it has a groove in it, so the string can go there. And then once that string is in the groove of the wheel, simply pull on it. And you can see our Lego characters are traveling up and down when I pull and release the string. And there you go, you have your own Lego crane. So let's dive into the steam behind this. So cranes are used to build super tall buildings like the CN Tower or the big skyscrapers that you see all over the cities. They have to hold and move really heavy construction materials that are far too heavy for construction workers to carry. And the crane is made up of the mast, base, gear, and motor, as well as the working arm, machinery arm, and operator cab. Now the mast would be like this part on our crane. It's the tall part of the crane that sticks up way into the sky and holds the arm, which would be this, in this case, this piece that sticks out here with the wheel on it. Now at the very top of the mast, there's a gear and a motor, which allow the crane to turn, as well as a working arm, machinery arm, and operator cab. Now, we don't have any of those things on our crane, since it is operated by whomever has built it by pulling on the string. But in a real working crane in the big cities, they would have those things. Now the working arm of the crane is also known as the jib, and it contains the motors in the crane as well as the large counterweights, just like our counterweight right here, which help to balance the crane. Now the counterweights balance out the load that the crane is carrying, so the crane does not fall forwards when it lifts up the load. Makes it even on both sides. Now, to get an idea of just how heavy a load the crane would need to carry, it's not uncommon for large cranes to lift about 4,000 pound loads. Now this is approximately 3 African bush elephants. So imagine instead of Lego characters in our cart here, we had 3 giant elephants, and that would be how much weight a crane can carry in a load. Now in a balanced style crane, the crane's beam is balanced at the fulcrum or balance point, which we talked about earlier with our cart. And this allows the crane's beam to act as a lever. Pulleys are also often used in cranes. We actually have a pulley right here, our wheel and string. A pulley consists of a wheel with a groove that a rope is run through, which can change the direction or application of a force applied to the rope, and can also reduce the effort required to lift the rope, or to lift the load. So, as you can see, cranes are quite complicated and powerful pieces of machinery. There are many forces that are at work on a crane when a load is being pulled up, from the tension or how tight the string is, to the friction on the pulley or the wheel, and how the friction is basically, it's kind of a push back for every time we pull forwards. Without getting too deep into physics laws, there is a law that states every action has an equal and opposite reaction. So in this case, our action of pulling the wheel and the string towards me causes an opposite and equal reaction of friction pushing the wheel back the other way, which means I have to work harder to lift the load than I would if there were no friction. There's also air resistance on the load, so the air pushes down on the cart as it's pulled up, and gravity as well pulls down on the cart as it moves upwards. Gravity is what is keeping us all standing or sitting, whatever you're doing, on the earth as opposed to floating up into the sky. So as you can see, cranes are quite complicated, and there are tons of other forces that are acting on them at any given time. And to learn more about this, I suggest you check out the websites in the description of this video. I've listed quite a few that I found quite helpful, that I quite enjoyed, especially when learning about this. And I'd like to thank the blog Frugal Fun for Boys, which I found this crane schematic on. Yes, I hope you enjoyed building it, and let's move on to our next activity. So we'll set the crane to the side and get started on some different concepts with an electromagnet. Now for this project, you're going to need some copper wire. You can see I have here. You're going to need a large nail or metal object. I have a screw. Tape it's optional, but I find it helpful, so I have some here with me. You're going to need a C or a D battery. I have a D battery right here. And then just some small metal objects. I have some bobby pins, some little screws, paper clip, a dime, that sort of stuff. And then you're going to require scissors or a wire stripping tool, but that is only if the wire that you're using has coating on it. As you can see, this one does not, so I don't need that equipment, but you very well might if you're using a different kind of wire than I am. So first, we're going to take our wire and then leave a little bit at the end, just like that, and wrap it very tightly around the nail. Just like that. So it's very tight, very secure. Now, as we wrap around the nail, I'll tell you why we're doing this. So, what we're doing is we're wrapping coils around the wire, or of wire around the screw or the nail that you're using. And the more coils that there are of the wire, the more powerful your electromagnet will be. Now, this is because, according to Northeastern University, electromagnets are made up of coils of wire with electricity passing through them. When electrical charges are moving, they create a magnetic field. So, as the electrical charges move through the coils on your nail, they are creating a magnetic field. And when you add more coils of wire to your electromagnet becomes stronger because the magnetic fields from each coil in the wire add together, creating a larger and more powerful magnetic field, and thus a more powerful electromagnet. Now that we've got a little bit, make sure to leave a little bit of wire on each end so that we can attach it to our battery, and then you can see all of the coils I've got around the nail here. Then I'm going to take my battery and tape one end down. Now, I found taping the screw to it worked just a little bit better because my hands were free to adjust the wire on either side so that it touched either end of the battery, like you can see here, and to pick up objects. Now you can see the bobby pin has stuck to the screw. Now, be careful when you are doing this. You may want to use gloves, something like that, quite possibly some adult supervision, of course, just because the screw or the nail that you're working with can get quite hot from the electricity flowing from the battery through it. So just be careful and be aware of that. Make sure to be safe. Now, as you can see, it's a magnet. Move it closer. You can see that the bobby pin is stuck to it. How cool is that? You've made your own magnet with just some wire, a screw, a battery, and some tape. It's quite impressive. Now, I suggest you play around with it, see what you can pick up, what you can't. What happens when you maybe remove the wire from one end carefully, of course. If it's hot, what happens if maybe you use it on a different battery? That kind of stuff, if you add more coils than what you have already. Just play around with it safely and experiment. Turn on your scientific mind and really have fun with it. Now, when I did this, a few questions came to mind, so I will address them. Now, the first one was, why does the magnet stop working when you take the wires off the battery? Now, this isn't true in all cases, as you can see. It does stick to it, not nearly as well as it did, but it does, and we'll get into that a little bit later. But the general answer to this question is because the energy that is flowing from the battery, so it goes from the battery through all of those coils all along the screw and back into the battery, that is forming what is known as a circuit. Now, a circuit, according to Tech Terms, a website which I have listed below, is a closed path that allows electricity to flow from one point to another. It's essentially a road for electricity, and when that road is interrupted, when it's blocked, the electricity can't reach the other point. So when you take the wires off the battery, or even just one wire, the electromagnet doesn't work anymore, or at least not as well, because you've broken the circuit. There's no way for the electricity to follow the road and go in circles. Now, another question I had was, why do some materials become attracted to the magnet and not others? So why does the bobby pin stick to it, but a Lego block, it wouldn't? You can see the bobby pin. Oh, our screw is not charged anymore, so it is not magnetic. But even so, I can put it back on our battery, just like that, and now it is magnetic. You can see the bobby pin sticks, but this Lego block, it is not sticking. Now, why is this? This has to do with the iron content in the substance. Now, iron is a very magnetic substance, and the magnetic properties of materials and substances depend on how much iron is present in them. For example, the bobby pin has more iron in it than the plastic Lego, so it is more magnetic than the Lego. And this can also determine why things are more magnetic than other things. So if you have a substance or a material with a higher iron content than this bobby pin, then that is going to stick to the electromagnet better than the bobby pin. Now, there are tons more questions to answer with that. Those were just two ones that I had right off the bat and thought I would look into for you. Now, since we have had some fun with that electromagnet, let's look at this one. Now, this is an electromagnet I made at home, and it is on a drill bit, and it is coated with, or covered with, copper wire in coating. So that is what the wire looks like when it has coating. Now, you can see the ends of mine are already stripped, so I don't need wire strippers or scissors or anything like that because they're already bare. But if your wire just didn't have the ends off already, you might need to use those. Now, this is a much larger electromagnet than this little tiny one that we have made. So, in theory, it should have a higher magnetic field because, as you can see, there are a ton more coils on this. There are several layers, so each coil has its own magnetic field, and all of those magnetic fields will add up together into one giant one and theoretically make this a much stronger electromagnet. So let's test it out. Now, always remember to be careful, of course, with electricity, but this one doesn't heat up near as much with the, at least in my experience. Always remember to be cautious though. Now this one, I put both ends of the wire onto the battery, and I can pick up lots of things, just like that. So I've got a paper clip, a bobby pin, some screws. Let's see, there's a dime that I've picked up. So you can see it's a much stronger electromagnet than our other one. Even though I am using the exact same battery, just because there are more coils of the wire, it is a stronger magnet. Now, let's test and see what happened, if what happened with the first one can happen with this one. So, the wires are off the battery, and yet it is still magnetic. And we saw this happen with the first one as well. So, why is this? This is because when I'm removing the wire from the battery, according to Physics Classroom, another website I've listed in the description of this video, the electrons that are inhabiting the same space, they don't like each other. They don't like to be in close proximity. They want to be as far away from each other as possible. And they're always looking for their own home, or at least a home with more room so they can have some more space. So the electrons from the battery make their way onto our drill bit here, and they stay there. So the metal of the drill bit is still charged with electrons even after we have broken our circuit. And it's charged for a fairly long time, as you can see there. Now, Electromagnets are super cool, and they have so many functions in the real world, a surprising amount. I was quite shocked to learn how many places there are electromagnets used. For example, the handheld portable speaker hooked up to your phone contains a small electromagnet inside of it, as do all devices with speakers. The electromagnet translates the electrical current into the music or the sounds, my voice for example, that you're hearing. Electrical devices that require charging, they use electromagnets. The solenoid valve inside washing machines, which turns water on and off, is an electromagnet. Garbage disposals, the drafts on some wood stoves, microwaves, induction cooktops, tape recorders, VCRs, and DVD players all make use of a type of electromagnet. Even cranes, like we talked about earlier, in junkyards use a super powerful electromagnet to pick up cars. Electromagnets are so useful because they're not permanent magnets. They can be turned on and off, just like your magnet can be turned on and off by breaking the circuit. Now there are some more mechanics in there with taking the charge out of the metal, but essentially they are magnets that can be turned on and off. Now to learn more about that, you can check out the websites in the description of this video, and always ask questions. Any questions that you have, I'm sure there's an answer somewhere on the internet, and if you can't find one, we have tons of books here at the North Hastings Public Library, and I am more than happy to help you search for an answer. Now, we've finished our experiments, and the video is coming to an end. I will leave you with a few reminders. Please make sure to check out our first 2 videos of STEAM TV on the North Hastings Public Library's YouTube channel, Science and Technology. I had a blast filming those and preparing for them, and I really hope that you like them. And you can also check out our upcoming art and math videos. You can check out tons of library resources, specifically Lego. We have lots of Lego in our experiential learning collection that you can come and borrow, just like you would borrow a book, and take home, and you can make a crane with me or whatever your heart desires. We also have tons of STEAM books that you can borrow and learn from. You can also check out the North Hastings Public Library social media platforms. We have Pinterest, Instagram, Facebook, and YouTube. You can check those out for lots more fun experiments. And again, there are tons of fun websites in the description that you can check out to help you learn about engineering. So thank you for watching today's episode of STEAM TV, and I hope you will check out our next few episodes. Thank you, and goodbye.